Number 15, find the point of diminishing returns, xy, for the function r of x, where r of x represents revenue in thousands of dollars and x represents the amount spent on advertising in thousands of dollars. So the point of diminishing returns. Return mean profit, return on your investment. Think about it this way. If your return on your investment is increasing at an increasing rate, then you're going to have this concave up, and the second derivative is going to be greater than 0. If you get to the point of diminishing returns, that doesn't mean that you're not having returns. It just means that the pace at which your returns are improving has slowed down. So that's concave down at that point, and that's where f double prime is less than 0. And this point, this x, is the point where your revenue or profit over here starts to diminish. Now, diminish doesn't mean go away, doesn't mean it's not still increasing. It just means it's not increasing at an increasing rate, it's now increasing at a decreasing rate. So that just means that we need to take the second derivative and find the point of inflection, or the inflection point, x, y. So we're going to start by taking our revenue and taking our first derivative. So we've got 0 minus 3x squared plus 84x plus 700. That's our first derivative. Our second derivative is going to be minus 6x plus 84, because the derivative of that's going to be 0. We set this equal to 0. Negative 6x plus 84 equals 0. Negative 6x equals negative 84. And then we divide to see what that number is. So negative 84 is going to be divided by negative 6. That's going to be x is a positive 14. Now we have to pay attention here because it says x represents the amount spent on advertising in thousands of dollars. So basically we're spending $14,000. And now we have to find the y value, or the function value, that's representing the revenue that's happening at the point where your return starts to diminish, and that is it starts to increase at a decreasing rate. So we have to put 14 into the original function. So that's going to be 11,000 minus 14 cubed, it's positive, I don't need parentheses, plus 42 times 14 squared plus 700 times 14. So I'm just substituting the x value we found back into the original, not into either derivative. So we've got to do 14 cubed. That's 2744 plus 42 times 14 squared. That's 42 times 196, and then 700 times 14 is plus 9,800. So let's see, that's going to be 11,000 minus 2744 plus 42 times 196. That's 8232 plus 9,800. So my final answer here, 11,000 minus 2744 plus 8232 plus 9,800 is 26,288. Now, just like up here, we had to pay attention to this 14 was actually 14,000. We now need to look at the revenue is in thousands of dollars. So the point is 14,26,288. That means that at the point we're spending $14,000 on advertising, we are getting a revenue of $26,288,000. Number 16, the average monthly rent for a 1,000 square foot apartment in a major metropolitan area from 1998 through 2005 can be approximated by the function below, where t is the time in years since the beginning of 1998. Find the value of t when rents were increasing most rapidly. Approximately when did this occur? So the key phrase in this problem is increasing most rapidly. So increasing means going up, and we could find that from the first derivative. When is it going up? But they don't just want to know when it's going up, they want to know when it's going up the fastest. And that's going to occur at an inflection point. Since these numbers are so tedious, I worked it out on paper so that it would be easier for you to read and easier for me to write. So you can look here and see what I did. So the first thing I did, here's my function. I took the first derivative. Of course, that's the power times the base to the power minus 1. And then another power times the base to the power minus 1. Another power times the base to the power minus 1. And then here we have the coefficient of t to the 1, so it's just that coefficient. I did some simplification by multiplying these numbers out. You can pause it and multiply them out in your calculator to see where I got these numbers. And then once I had it simplified, I took the second derivative by using the power rule again. So power base, power minus 1, power base, power minus 1, and then coefficient is just going to be that number. Simplified all that, and I came up with a quadratic equation. Now the thing about quadratic equations is you either have to factor or use a quadratic formula, and of course we're not going to factor this with all these decimals. I wrote a reminder here, increasing most rapidly means increasing at an increasing rate. Where is it concave up? An inflection point. So I identified my a, b, and c for my quadratic formula, which is the opposite of b plus or minus b squared minus 4ac all over 2a. So for opposite of b, I put the opposite of this negative 144.69, that's why it's positive. Plus or minus, I've got a b squared, and then I've got a minus 4, the a value, the c value, and all of that is over 2 times a. And so working down, first I squared the 144.69. I did my multiplication here. That gave me the 9841.12896. All of that on the inside of the radical became 11,0674. I took the square root of that, and that finally got me down to this expression, 144.69 plus and minus 105.3284 divided by that 39.264, which is the 2a. That results in two values, so I had to do the 144 plus 105 divided by that, and the 144 minus 105 divided by that. So one came out to 6.368, and the other came out to 1.002. Now, we know that it's going to happen at one of these inflection points, but we don't want to look at the second derivative here. We want to look at the first derivative, which tells us it's increasing. Where is it increasing most? So we put this into the first derivative, and in one case we get a negative, and the other case we get a 65. So this is the maximum one of those two. So that occurred at 1.002. So that's, the rents were increasing most rapidly at 1.002, 1 year after the beginning year that they gave us, 1998. So the second thing they ask us, well, what year is that? Well, if it's about a year later from 1998, that would be 1999.